Morgan Hayes. I am an assistant professor, extension professor in the department in biosystems and ag engineering. And I work primarily with livestock. So I work a lot on facilities, structures, different areas related to livestock. In my personal life, I have a cattle and hay operation down in Boyle County, down near Danville. So I'm pretty familiar with putting up hay. We put up quite a bit of hay. We buy and resell a bunch of hay as well. And so you're probably going to see some biases in these slides. A lot of these slides were put together by Dr. Jackson, who is sort of my counterpart in the department. And he also has a cattle and hay operation. So you'll see some of his biases and some of mine, and you'll probably hear us maybe talking a little bit about what the slides say and our perspectives on it. Feel free at any point to ask a question. You know, there's plenty of slides up here, but if there's something you really want to talk about, we're happy to discuss it further.
Okay, so I'm Aaron Turner. I'm an engineer associate in BAE, also a PhD candidate. Related to this, most of my interest in hay type things is when actually in biomass harvest and transport. I also work a lot with harvest logistics, and so that's really the part of it that I get excited about.
And so sort of our perspective on hay equipment is the overall goal of the hay machinery is to try and optimize our forage. Just out of a raise of hands here, how many people in this room are looking to raise hay to feed to their own cattle, sheep, goats? Most people. Anyone looking to raise it to sell? A few people in here. Anyone looking to sell into the horse industry? A few people in here. Yeah. There's some real opportunities in this state to sell hay, I think, as long as you can put up a pretty good quality hay and sell it correctly, market it properly, and be pretty consistent in your products. And the reason you're using some of this machinery and making decisions about machinery is to try and do that. And certainly from your own animal's perspective, the better the quality of the forage, the better the animals perform as well. So when we talk about putting together groups of machinery to maybe bale hay, we're trying to really optimize that yield and quality, but we want to be cost effective. You know, there's certain pieces of equipment that would be wonderful to own, but they might not make sense cost-wise on a smaller operation. So we're going to kind of discuss what the pieces of machinery are and then maybe give some perspective on how costs might play into this. You know, the nutritional requirements of cattle, of smaller ruminants, of horses, have a lot of different factors that go into them. And so ideally, when we're putting up our forage, we want to put up the best forage we can for the animals, but we also want to know what our forage quality looks like, so that's why we talk about testing and doing things like that. The other challenge with machinery is that we got to get our hay out into the field, and this is what it looks like this year for a lot of us. I know personally that on my farm, we have been struggling with mud. So we can do everything right on the machinery side, putting our hay up, but if we're feeding it like this, a lot of things go downhill pretty quickly as well. The alternative is some of these pads. If you are interested in talking about how to feed hay on a pad, I'd be happy to give you perspectives. This is a pad that I put in on my farm this year. In fact, I have two concrete feeding pads on my farm that I feed hay on. And so I will give you my honest opinion about it afterwards. I know that's not the purpose of the machinery talk, but I'd be happy to share my perspective on that with you as well. One of the things about the machinery for a hay operation is that there's a lot of money invested in it. And certainly, depending on the size of the operation, the amount of cost that we have to put into this machinery may not be effective if we're only putting up 20 or 30 or 50 round bales a year. So we certainly have to sort of balance out those costs with the amount of hay we're putting up. There's a lot of time involved in managing this equipment, keeping everything running, and we'll talk a little bit about the maintenance on the equipment today. The ease of the operation, you know, some people are willing to invest in slightly cheaper equipment that's used. understanding that they're going to spend more time and energy maintaining the equipment. Other people will go the other direction. It's something to sort of keep in the back of your mind. And some things hook up easier than others, and run quicker than others. One of the important considerations is really how much hay you're trying to put up. The speed of the operation. If you have to get up 100 acres at a time, the type of equipment you need, the speed at which that equipment has to run is very different than if you're putting up 20 acres at a time. The number of drying days. We live here in a spot where our drying days are fairly limited. Weather-wise, we can't predict 4 days dry a lot of times in June or May when we need them. So sometimes we have to make strategic choices in our machinery to try and get our hay drier faster that perhaps we wouldn't have to if we lived in, say, Wyoming. You know, maybe we have a little different perspective on the type of equipment we need. We have to understand what kind of harvest loss we're willing to accept. If we're leaving some grass in the field, is that a problem for us or not? Again, those repair costs, I think they come in a big way for a lot of people in making decisions about equipment.
Yeah, sure. So going along with that, being able to get things done in a timely manner, you know, it really becomes a big deal, especially if you're trying to maintain quality. So if it's important to you, especially if you're trying to market to horse industry or something like that, being able to, you know, hit that narrow window. So that's something that you have to consider, and you know, you probably need bigger machines if you want to get the harvest done in a tighter window. So I guess next we'll talk about some of the cutting options. Primarily there's two types we'll talk about, a sickle bar mower and a rotary disc mower. So a sickle bar is the oldest, the original ones. It's cheapest and it's lightweight. It's probably the lowest cost option. You know, it does a pretty good job. Problem is you're limited on speed, so it's probably one of the slower ways to go. And you're also, anytime you have a heavy crop, you can run into issues with clogging and those sort of things. Yeah, you're nodding. I'm sure you've done that. And it's also, they have knives that have to be maintained and go through and make sure and keep those sharp. The other option is a disc mower. You know, lets you go through and do things quite a bit faster, less likely to clog. Problem is you have to spend more money. 3 to 7 horsepower per foot is kind of some of the data, but that's PTO horsepower, so that's like power to actually cut the material. So tractor size, you would probably want to be quite a bit larger than that, just to be able to handle the weight of the implement hanging off the back and be able to move and those sort of things. And the other thing is, if you have dual knives, that can really increase the horsepower requirement. So the nice thing about these is you can flip the knives over, so helps you out a little bit there. We've got a couple things as far as condition options. A mower conditioner versus a flail. Winter really depends on the crop and what you're trying to do. So, you know, a roller conditioner is good for anything with a big stem and things if you care about preserving leaves, you don't want a lot of leaf loss. Those will probably be your best option. If you want to dry down fast, a flail mower really will give you, in that first day, you'll dry down a little bit faster if you use a flail mower. And if you look at some of the fuel and power requirements between the two, I guess the three, so the cutter bar has the lowest power requirements, lowest fuel use. A disc mower with a roller on it is somewhere in the middle, and then if you were to use a disc mower with a flail, it requires 67% more horsepower for the same operation. And so when you're talking about adjusting the spacing on these, really you should just be adjusting the rolls so they don't touch. So about 1/8 of an inch gap is probably what you'll need. And it's usually just one adjustment per side. And you can go through and we'll show a little bit where you talk about where you can check and see how well you're crushing. Yeah, so if you break that out, that gap there should be roughly 1/8 of an inch. And again, the timing of them shouldn't need to be adjusted. They should run together and make sure that they don't hit. And next thing, we just have a couple pictures of some of the different stuff. So there's the adjustment gap for the roll. Other thing is you can set the pressure on the roll, so that would be where you would adjust that. Yeah, I guess there's the picture of one. You kind of see the cylinder there in the back. Okay, so when you look at the crop, really what you want to check to see how well you're conditioning it. You want to look at the stem, see if you can see crimps and crushes in it. So if you see it, it should break the structure of it and allow more surface area in there and allow the moisture to escape is really what you're after. So 90% of the stem should have some damage to them. So if you're under conditioned, check that gap, or if you're over conditioned, you can check how much pressure you have on it. Would be two spots to look at. The other one would be a flail. There's two adjustments there. One would be to adjust how close it is to the blades, and the other one would be, I'm not sure exactly, do you know what the liner was? Did you ever figure that out?
It's just a way that you can get a different surface there.
So it just makes it, or in the concave, makes it so the gap's not as big, so you get more crushing action in there. When you're looking at cutting height adjustment, so primarily one of the ways you can do this is with changing the shoes on a mower. So, they make these for, especially people that do biomass type stuff. It's basically, instead of having the shoe where it runs real low, they have some cool offset spacers to get a little bit higher of the cut height. And those are going to be machine dependent, and I guess you can adjust the top length to some degree to get a little bit of height variation in there.
So this is probably one of those things that Josh and I disagree on. So the slide's going to tell you one thing, and then I'm going to give you my perspective on this. Tedders here in Kentucky are a way to increase the amount of drying you can get in an amount of time by fluffing, turning over your grasses so that new areas get evaporation. The paradox that he points out is that in a wet year, you have plenty of hay coming out. So in the wet year, when you use the tedder because you're very concerned about rain coming in constantly, the volume of grass you're actually getting out of the fields tends to be high. So to spend the time and money to run a tedder on a wet year might be ineffective cost-wise because hay is not as valuable. On a dry year, when the hay has a lot of value, you probably don't need to use a tedder. You don't need the cost and time commitment to run over the field an extra time. My personal philosophy is I sell hay at a high quality and I get a premium for it. I'm going to make sure all my hay gets dry, that I don't have wet spots in my roll. So I'm willing to spend the expense and the time to run a tedder on a field on a wet year because I still need the highest quality grasses in my hay for my operation. So there's sort of a dichotomy there. I think there's a little bit of a challenge in how economically a tedder falls into an operation. There's definitely a time and a gas cost associated running a tedder over a field. The equipment is not cheap for how simple the design is. Tedders are not a cheap piece of equipment to own. And so there is a significant cost with that. But it does reduce that drying time. So if we're on a tighter window and we want to get hay up quickly, we can do that. We're going to talk a little bit more about drying a little later, and you'll sort of see where that might help. Here it is. Perfect. Next slide. So hay drying strategies. These are sort of some thoughts from the cutter and the tedder and all of that, how we can dry hay faster. And in Kentucky, we probably need to know how to dry hay faster when we're trying to get that first and potentially even a second cutting in if we're doing alfalfa. A wide windrow. So if you're looking at your mowers or your mower conditioners and looking at how that hay comes out on the back side, that windrow that comes out of the back of that mower, if it comes through like a 12-foot wide cut on a 9-foot swath, it will drive 35% faster than if it comes through on a 6-foot swath. So if that back end is narrowing a 12-foot down in half, 35% more time to get that hay dry than if it pulls in at a full 9-foot swath. That's the reason that the tedder tends to make it faster, because it puts everything back out over that whole 12-foot again. Make sense? The next thing is that cutting height. Because we get a lot of rain and our ground tends to be fairly wet, if we can cut a little bit higher than we might traditionally cut, we can get some airflow underneath the bottom of that mass that we've let drop behind that swath, and we can get some better drying as well from that. I will say that there is a contingent here. There has to be a good enough stand of grass to be able to hold up all that material we're cutting down. So sometimes on a poor stand, we won't be able to even if we cut high, we won't be able to get that to stay off the ground. When we condition hay, we can get drying rates of 15 to 25% faster than without a conditioner. That's a fairly significant increase in our speed for drying. And for those real large stems, the alfalfa, that's sorghum Sudan grass, some of those volumetrically important or high dollar grasses and broadleaves, we can still save a day over a flail conditioner. So in my opinion, for most things, the cost to do business with a roller type of conditioner is probably going to be more effective for most people. I know there are some people that might, do some unusual grass and maybe a flail makes sense, but for the operating cost on the fuel, the amount of horsepower you need on the tractor, and whatnot, I think those roller conditioners make a lot of sense. Also, the tedder here can increase drying rates by 15 to 30%. One of the things that the tedder tends to do is it tends to do some of the same things that a flail does. It turns all that grass, it flips it out, it makes it all kind of wonky, so there's a lot of air pores through there, so it dries pretty well. The other thing it does is it tends to shatter leaves. So one of the challenges with using a tedder is that if you use it incorrectly, you can decrease the amount of grass or broadleaf, alfalfa, whatnot, that you're getting up because you're knocking those leaves off as it starts to dry. So if you're going to use a tedder, the recommendation is to do it the morning after you cut while the dew is still on the ground. If you're not doing it that way, it needs to be done probably in that first 6 hours after cutting. I think it says here 3 to 4 hours on one of the recommendations. It depends on which one you're looking at, but the drier that grass gets, the harder it is to use a tedder on it effectively. And this here is just sort of an interesting figure here from a Wisconsin study. And they're looking at drying with a narrow versus that wide swath here. And you can see how fast the initial drying happens if we give ourselves a little more space and surface area for that evaporation to come off of that grass coming out of the mower. Rakes. Okay. Rakes are kind of an interesting piece of equipment. There's a variety of different options out there. How many of you use a bar rake? I got some hands. Bar rakes are the oldest design. They're pretty simple to maintain. They have very little maintenance cost associated with them, and they tend to be narrow. They tend to have a learning curve to being able to run one well. But if you can run one well, they're pretty nice. They have side delivery. They do have some dolly wheels, so you have some pretty good turning radiuses on them. Although I have seen people turn them back onto the tractor, it does happen. I've done it. The one thing about them is that there is the opportunity to run multiple bar rakes in series to try and maybe get a wider pull with the bar rake. It's also easier if you're running through a thinner stand of grass to run maybe more than 2 rows together, because you can kind of move rows over to get a full windrow that you want to pick up with the baler. So I'm not opposed to the bar rake, and you can usually pick them up at a reasonable cost used, and they don't have a lot of things that go wrong on them. So you can usually verify whether or not they work. If they spin, you're probably okay to use one of those. Wheel rakes, there's a couple different designs on wheel rakes, but these tend to be a V-rake. They tend to have 8 or 10 or 12 wheels that sit down. Usually you can adjust and pull up 1 or 2 of those wheels depending on how it's set up. And they just kind of pull all of that hay into the center. They also can do a side delivery, so there's both methods. Around here I see more V-rakes than I see side delivery wheel rakes, but both do exist. And then there's a rotary rake, and we very rarely see rotary rakes around here. It basically runs across the ground and pulls all the way around. It's sort of a weird design. It's very effective. It picks up a lot of smaller stuff out of the grass. It's very good at picking up all those losses that you might pick up with the other two or achieve with the other two. So the challenges with rakes is that when we get into trickier substances, we tend to get them wrapped around the wheels. I don't know if anyone's ever done this before. No. I have. So one of the challenges is, especially on something, for instance, I baled some forage beans a couple years ago, and they wrap. And I spent hours and hours and hours trying to cut it from around the rotation point on the rake. I ended up using a bar rake because it's a little bit easier to manage on something that tends to wrap. But the wheel rake is much faster when I go through the field. So it was a trade-off I had to make. These wheel rakes, these points will pick up just about anything. They'll pick up old twine. They'll pick up anything that's out in the field that's one of their characteristics. And if you're really bad at riding one or you have a lot of rust, I guess you can lose the whole wheel too. I've never done that yet. That's not a promise that I won't do that at some point. But they take a lot of pressure. The way the wheel rake sits down, all those wheels are basically taking the ground and running on the ground. So you're basically using the hydraulic to leave them pushing down. So there's a lot of tension on the point where that wheel sort of sits into its arm. Does that make sense? So this is a disclaimer, personal preference. This is Josh's disclaimer and personal preference. Side delivery, bar rakes are really good for thick, wet crops with lower ash content. I agree with him. If you have a thick, wet crop, this is a really good option for you. Also, if you have a really thin crop, really thin, this is a way to, get a couple rows together at once. That V wheel rake is by far better if you're trying to get through the field fast. You're going to accept that you're going to leave a little bit more grass on the ground. You're not going to be able to pick up quite as much of those smalls into your bale because the wheel rake doesn't pick them up quite as effectively. But it picks a wider area on that first run. Typically, you can run this and then run your baler right behind it. So if you have two tractors and you can run two pieces of equipment one after the other, the speed on this is significantly faster. Your efficiency certainly matches that.
All right. So first thing on balers, we'll just start with the pickup. So one thing that's really nice to have is to have a wide pickup. Does a couple things for you. If you have pickups wider than the actual bale chamber, that allows you to have a wider windrow. It also helps you get nice square shoulders on the bale. It keeps you from making triangles and that kind of thing. Especially if you have like a bale monitor and you can see, it can really help so you don't have to weave through the field. It helps you drive a little bit straighter. And you can kind of see, typically what happens is you have pickups wider than the bale chamber. Bale chamber starts there, and there's just some, there's some feed augers on the end that feed that crop in to help you make sure that you're getting crop across the hole with the bale. A couple things you want to talk about. Bale size consideration. I know Morgan's probably going to have opinions on this too. So you've got a lot of opinions, and so this table shows the horsepower requirement as you go through bale size. So you've got 4x5, 5x5, 4x6, 5x6, and then through the 3x4x8, big square bales in there too. So generally, as you go up in bale size, your power requirement goes up. But again, this is the same thing. This is PTO horsepower, so that's how much power it takes to make a bale, but that's not going to stop you or help you go up a hill. So you definitely, on tractor size, would probably want to be quite a bit higher than some of those. I would say you probably want to be, yeah, I'd say, I don't know, for a square bale, you probably want to be around, 200, something like that?
No less than 180.
Yeah, and then on the bigger round bales, probably 100 maybe? Okay. Yeah, but the thing you see is as you go up, so if you look at a 4x5 versus a 5x6, 5x6 has twice as much material in it. even if you go from a 5x5 to a 5x6, that's 40% more material in that. So that basically translates to you having fewer bales you have to pick up out of the field, and you also spend less time tying, so you're actually able to harvest material faster just by going with a bigger bale size. And let's see, this has some average weights too. So probably all pretty good. I think that one's probably a little bit high. It would probably be more in the 1,100 pound range realistically. But you have to make that match as well. If you're making bigger bales, then you have to have your transport equipment be able to match it. And one thing, I don't know, 4 foot wide bales, that's a couple things about them. One is, they have a tendency to kind of fall over. They're not quite as stable standing on end, but if you're transporting them down the road, if you're transporting them too wide, then you're only 8 foot wide versus being 10 foot wide and taking up the whole road. So density, this is talking mainly about round balers here. There's a bunch of things that influence bale density. So if you sell it, just a certain size bale, there's a number of factors that go into actually how much material is in there. The size of the bale actually makes a difference on how dense it is. If you're making bigger bales and when it's spinning in there, you have more weight on top, so it compresses it down more. The crop makes a difference on how well it packs together. Moisture content also makes a difference, not just because you're adding water, but just because higher moisture material actually will make a denser bale with more dry matter in it. And travel speed is related to just how much material you're putting through the baler. If you're running really thick windrow, they'll be a little less dense because the lighter material going through, it's a thinner mat coming in, so it's less material to compress. The other thing is baler settings and maintenance. So again, looking at a round baler, if you're looking at one of the variable chamber ones, there's a pressure setting that sets how much tension you have on the belts going around. So that also directly affects how dense the bales will be. So this just breaks down that the bale size and transport them out of the field a little bit further. So this is the same size bales we talked about before, but now, if you had the same area, so this is per acre with a constant yield. If you had a 4x5 bale, you'd have to haul 13 bales out of the field approximately. And if you went to 5.6, you'd only be hauling 7 bales an acre out. So, it's less trips through the field. When you go out to feed later on, it's less bales to haul out into the mud. But then there's also trade-offs. You have to have higher horsepower to make them, and you have to be able to transport them down the road. So if you're going any distance, there's definitely trade-offs there. You want the bigger bales are easier, especially if you like the square bales. They're probably the best for transporting long distances. I would say probably those. I don't know. What do you think about 5x6 versus the other ones?
I think it's a challenge to transport a 5x6 bale. I also think it's a challenge if you're trying to sell to someone to have equipment to be able to pick up
That's a good point.
a 5x6 bale. And I think a lot of people have tractors that don't handle a lot over 12 or 1,500 pounds, and they really shouldn't be over 1,000 pounds for most people that have a 40 or 50 horse tractor if they're moving hay around with the front end loader on it. So I think there's a bit of a balancing act on that.
Yeah.
But that 5 foot wide is certainly a bit of a challenge for a lot of people. So the next slide's a demonstration.
All right. Hey, yeah, there you go. So yeah, 5 foot wide bales. So it's 10 foot wide going down the road. If you haul them 2 next to each other, definitely probably okay if you're going short distances or don't have to get on, go anywhere real far on any major roads. But it's definitely something you have to balance out what works best for your operation. And just general guidelines. It's always good, especially if you're hauling really wide stuff, to make sure and have some hazard lights and some signage, especially we're engineers. We got to plug those sort of things. All right, so wrapping options. There's a few options. You have sisal twine, plastic twine, net wrap that goes right to the edge of the bale, and then net wrap that actually goes and covers around the edge of the bale a little bit. If you're curious and want to look at it work out for you, Deere and Vermeer both have calculators online where you can go through and put, how many wraps you do and your spacing and your twine price and the net wrap price, and it'll give you help you break down how much more it would be actually per bale. Again, so if you use twine versus net wrap, twine's cheaper. It's easier when it comes time to feed. If you're not using plastic twine, you can kind of just set it and forget it. Net wrap is faster, so you're spending less time sitting there wrapping the bale. You can get, some of the studies showing you get 30% more bales made using the net wrap. But you also have to balance that against the initial cost for the net wrap on it. So 15 to 25% of the purchase price of the baler is what this study found. But you get bales that look nice. They store better. You know, they have, I think Morgan's going to talk about some of this, but shed water better. They stay together a little bit better. And some of this, you know, look at 90 cents to $1.20, somewhere in that range for price per bale.
Those figures are not current.
Oh, really?
Yeah, 2009, and I believe it's probably double what they're showing.
Really?
Yeah.
Okay.
I agree.
Good to know.
I said the same thing. I think that putting net wrap on one is about 10,000, 8 to 10,000. So
8 to 10,000?
that's my personal perspective on it. But I think it's still 15 to 25%. I think that percentage is still right based on the cost of the baler. But the cost of the baler's gone up quite a bit.
There you go. All right. Okay, so this is that same study that looked at the actual productivity of it. So 2 different size bales, one wrapped with net, one wrapped with twine. You know, really the difference comes if you're wrapping a bale with net, you spin the bale maybe 2 to 4 times depending on how many wraps you put on. Or if you're doing twine, it might be 20 to 30 times to spin the bale. So on the small 4, for some reason he was making 4 by 4.6 inch feet bales. It was net wrap took 20 seconds to tie. The twine took 47 seconds to tie. If you went to the bigger bales, it was 22 versus 75. So pretty big difference in tie time. And you can see the number of bales per hour is where the difference is. So, you know, 38 bales per hour with net, 30 with twine. On the bigger bales, it was 15 versus 11.4. You know, this kind of shows some of the trade-offs that you can have. So, you know, you have a smaller bale. If you look at the total amount of material you can harvest in an hour, smaller bale with net is better than a smaller bale with twine, but a big bale with net is the best. The small bale with twine is probably your worst. So that's kind of where you kind of see some of those trade-offs. I don't know if that makes sense between how fast you do it. Of course, this is just on how quick you can make bales, right? I know Morgan's going to talk about storage and some of the other considerations with it here in a second. Yep, right now.
So this is probably one of those spots where I maybe differ a little bit again from Josh. Storage loss-wise, net wrap versus sisal twine versus plastic twine. This study looked at all 3 sort of in comparison, and it looked at them specifically on a gravel bed, so it wasn't sitting in like mud on the bottom, but it was sort of wet on the bottom. It wasn't perfectly dry. It wasn't a well-drained surface, but it wasn't, you know, super wet. The net wrap only lost 7% of dry matter over about a 30-week storage time. The sisal twine lost 20%. 20% of the dry matter in that bale was lost on outdoor storage. And the plastic twine only lost 11%. And there's really no difference between plastic and sisal twine other than sisal twine rots really well. And so the bottom of that sisal twine tends to be rotted off when you go to pick it up after 30 weeks. And you lose the bottom of that bale. So when you go to weigh it, you have significantly less. I'm not really sure if you're feeding your animals, if that's a real perspective that you should be using, because the bottom of the bale that's still under the plastic wrap is probably not particularly edible to the animal. From a nutritional standpoint, it's still not in great shape even though you picked it up and moved it and weighed it in terms of the dry matter. So there's a little bit of a give and take with that sort of study. You have to take it with like a grain of salt. But if you're just looking to move bales later in the winter, the plastic makes it possible to do that a little bit easier. They don't tend to blow up in the same way that the sisal twine bales tend to. The net wrap obviously has the lowest here. I'm going to show you another study, slightly different findings in it, which I think is interesting. This is a study from Michigan, and actually it's from the 90s. It's an earlier version of net wrap, and it was not nearly as effective. So this study is looking at twine stored inside a barn versus plastic stored outside. That's the marshmallow. Versus net wrap, which is stored outside. This is an older version of net wrap, I have to say, although I found this kind of interesting. And then twine stored outside. And so basically, it looks at moisture content at harvest and again after 30 weeks of storage in that outside 4 inches on this bale versus what it looks like in the center of the bale. And I think this is really kind of an important thing to think about because when we talk about managing our bales, this outside 4 inches on a 4x5 or a 4x4 roll is about 35% of the hay. So when we talk about having weathering happen on a couple inches on a bale of hay, it makes a significant difference in terms of the volume of quality forage we're getting out of our bale. Make sense? Yeah. It's one of the advantages of going to a 5x6 roll and stuff is that we can actually get a larger volume not in that outside 4 inches. So this study was done with outside storage on pallets on a well-drained gravel pad. But you can see here that after 30 weeks of storage, our moisture content in that outside 4 inches on both the net wrap and the twine was above 35%. You know, it was a properly baled hay, baled 15, 16% on the outside, 14, 15% in the middle of those bales. There's a lot of variability when we go to pull samples of hay. This is not significant differences between these numbers on the initial numbers, but that 35 is significantly different from that hay stored inside, which is still at 14%. So in my mind, this is a compelling reason to think about indoor storage. I personally, I buy into indoor storage. I think it makes sense. I certainly think if you're long-term invested in your own land, it's a good investment. I think if you're feeding on someone else's land, or you're trying to sell to other people that maybe don't have storage on their land, maybe net wrap makes a lot of sense for those types of operations. But I think if you're feeding in one spot on your own property, a barn is probably a pretty compelling argument here. It's a little bit cheaper to bale them, even if it takes a little longer. A little easier to feed sisal twine bales. Don't have to go off and cut everything all the time. So probably my personal preference is coming through pretty clearly here on this one. But I'm definitely a barn storage over a net wrap. That's very much the opposite of the other person here in this room. And so I think there's probably a really good discussion in this. There's really reasons to do both. We don't disagree that the net wrap is faster, but I would argue that I don't go that fast when I drive on the hill anyway. Here in central Kentucky, I can't go 5 miles an hour across my field with a baler. It just doesn't happen on the land that I bale. So for me, the time commitment, I already know I can't put that many acres down at once, and most of my fields aren't that large. So I'm willing to accept a little bit slower on my baling, a little bit better storage, probably be able to sell it for a little more money because indoor storage will sell better. And then, on the other end, I don't have to cut every string on every bale every time I put it out in the field. It's for my own cattle.
And what says if you guys have, I want to hear his take.
Yeah, go ahead. Bring it up here.
All right. Well, so I like it because it's faster. It's especially primarily, I guess I'm thinking about this mainly from most of my experiences on the actually baling part of it. So I don't really do a whole lot with the storage and having to worry about it feeding it afterwards and cutting strings off. But so really, especially if you're trying to hit a tight window, like you can see rain clouds in the distance. To me, I think it would be worth being able to bale 8 more bales in an hour if you're really trying to hit a tight window. So I think that's for sure it's worth it. If you have outside storage, again, I think Morgan brings up a good point. If you want them in a bunch of locations, if you're feeding from a bunch of different spots, it's nice to have it there. Or if it's not if you don't have access to indoor storage, I guess would be no. But yeah, really just, I don't know, being faster and being able to beat the rain and stuff like that. I know it's, a lot of the stuff I've done is building wheat straw, and so June in Kentucky it rains a lot, so it's really nice to be able to get it out.
What I have personally found is I've baled with sizzle, with plastic twine, with net wrap, and I personally prefer the net wrap. But what I have found is that net wrap, unless you're buying brand specific net wrap, it's as much as sizzle twine. It's the same cost per bale when I calculate how many wraps I put of the sizzle twine on versus my net wrap, and it's quicker. I mean, you say, like that last slide showed, how many more you can bale up, in your hour time. So even if you're going to store it inside and you're looking at sizzle twine and net wrap, it's the same money. Still seems like a better option.
Yeah, I think really what gets a lot of people is the initial buying the baler with the net wrap option on it. I think that's it's a big, even if I guess my numbers are low, that's a big chunk of money to invest in it.
Yeah, so I consider, this is sort of one of those interesting questions, right? You're purchasing upfront that capital cost to put that net wrap into your baler. There's sort of two things you got to keep in the back of your mind. You'd have to pay some amount for storage if you're going to put it into a barn too, and it's probably not that different cost-wise for the two things. The amount of money you're investing in one or the other. Your lifespan might be a little bit longer on a barn. On a hoop barn. I should say on a hoop barn. If you're going to put up a metal barn, your lifespan will definitely be longer, but the cost will definitely be more. The other question you have to ask yourself is, if you go to sell your baler after you run so many bales through it, if you're a larger producer, if you're going to run 5,000 bales and get rid of a round baler, is there extra value in having that net wrap option when you go to sell a used baler? Or trade-in value? Is there extra trade-in value on there, and what is it? Those are really questions you have to sort of determine for yourself. And it depends a little bit on who your dealer is and what they're willing to do on it. So, in my mind, this is probably one of the biggest questions. When you go in, the baler is very expensive. It's a big investment to buy one. Choosing the right options is pretty critical. I would choose one set of options for the type of business I operate, but I can see the value in net wrap for a lot of people. It's just a significant cost up front if you're not really going to need it.
I guess it also depends on how many acres you've touched on this too, how many bales you're making in a year too. If you have more bales to spread that fixed cost over, it can help. Or if you have just, a lot of acres that you have to get done in the course of the year, it might be worth it.
Yeah. Any other thoughts on net wrap? I'm curious to hear if other people have strong opinions about it. The other thing I will say is, I'm going to sound like a real hippie here. I'm going to go ahead and do it anyway. I personally hate having giant piles of twine or net wrap sitting around on my farm. And you can spend an awful lot of time getting rid of those piles. You're not supposed to burn them. I'm just going to throw that out there. I don't know how many of you do, but it is a significant volume that you have to get rid of depending on how many animals you're feeding. So that's probably also part of it for me. I don't visually like seeing them in my barn or on outside of my barn. So, but yeah.
Why can't you burn the twine?
The sisal you could. The plastic twines they're plastics. People do. I just am not going to encourage that.
Oh, we burn the sisal.
Yeah, the sisal is fine to burn.
What about the net wrap? Is it biodegradable?
So they've done a bunch of work on both the net wrap and that orange plastic twine. And technically the orange plastic is labeled as biodegradable, and some of the net wrap is as well, but I don't know if it's like a 25-year biodegradable. It's not particularly fast biodegradable at this point. But some of them are labeled that way. They're certainly moving that way. I've seen some interesting preliminary stuff actually out of England, where they're looking at putting net wrap into a digestible form. So if you put it out there, if the cattle ate it, it would digest. There is risk if you put it out there and it's not digestible that you will literally fill up their rumen, and then they won't have room for other things if they're eating the net wrap. So don't go feeding net wrap. I'm not telling you to do that, but they're working towards making a product that I think would be a more palatable to me product. I don't know if that helps, but I think they're working towards it. I just don't think they're quite there yet.
What about that marshmallow wrap, plastic wrap? What do they do with all that?
It's an awful lot of waste, isn't it?
Burn it.
Uh-huh. I didn't say that. I did not say that. No, I mean, a lot of people are using that for doing baleage. So they're using it on a high moisture process. And there is certainly value from a sugar standpoint in doing that, but there's an awful lot of waste. And the cost on that, if you think the cost on net wrap as an option is high, the cost to put up plastic, most people rent the equipment to do that if they're doing that, but to purchase it is very significant as a cost. Some dairies will buy it, but other than that, I think most people can't afford unless they're doing an awful lot of wet bales.
About $5 or $6 more a bale to do beverage than it is to net wrap it around that.
Yep.
And that's not including the wrapper. That's
Yes, that's just the actual material, yeah.
Yeah. Plastic and the labor to wrap it, not wrap it.
Yeah, so people do it. I mean, and there's certainly reasons to do it. And around here, I think on your first cutting, there might be reasons to wet wrap
That's
hay.
what we've been talking about is, because the first cutting is always hard to get.
That's absolutely true.
Now I've got more hay wet on 20% chances of rain.
I know. Yeah, no, absolutely. So, I mean, I think there are a lot of options out there right now. I was at the National Farm Machinery Show a week or two ago, saw a lot of options for the plastic wrap, the marshmallowing and things like that. And it makes a lot of sense for some operations, but you have to be pretty strategic. Also, sometimes if you're renting the equipment, you have to be pretty smart about getting put on the list at the right time to make sure you can actually get it when you need it. Sometimes there is a struggle to find it. Yeah. So, but, you know, a wet bale makes sense nutritionally a lot of times over waiting for it to dry out. So,
What I found just recently replaced my baler, and that was for me, I decided net wrap was a priority. I wanted something with net wrap. And what I found, I do not have $75,000 to go out and buy the baler I want to buy.
right.
And so I had to buy a used baler. And what I found is that the cost, the increase in cost to be able to get a net wrap capable baler with 5,000 to 10,000 bales on it, being a used baler, really wasn't a ton. I mean, it was not a huge difference to be able to get a baler with net wrap versus without net wrap. So if you're looking at the used option, I don't think that the initial cost or the initial investment is quite as high as if you're buying it new.
Yeah, I think that's true. That's part of my concern with if you're buying new and choosing that option. I don't know that there's a lot of value on the back end on it if you're selling it. So if you're a high volume throughput kind of person, you know that you don't have a cost on the end to maybe justify it. But if you're doing that kind of volume, you might need it anyway, just for the speed. So yeah, it's definitely interesting. I think this is probably the biggest struggle most people make is deciding what they need. And then you look at some of the higher end balers like the McHale's and stuff, they only offered net wrap as an option. So, I mean, clearly they see for their audience that that's a demand. So,
I'm just kind of curious real quick for you. How many people like twine versus net wrap? So let's see, who likes twine?
If I'm storing inside, I like twine. Otherwise, I won't use it at all and wrap everything in that.
yeah.
Normally do.
Yeah, and I know a lot of people that have land, you know, that's not theirs and they're feeding on it. And it's a big deal I mean, you can't store inside on someone else's property. You don't want to be hauling over 8 bales at a time on a wagon. You want to be able to store a significant portion of your hay there. So I think that is a big question that you sort of have
selling
to...
it, net wrap is well worth it. I think you're gonna be moving it more than once. It looks better, transports better,
Yeah,
and it does bale a lot faster. It makes a huge difference.
yeah.
I figure figured out net wrap versus, I do a lot of custom baling, so I don't even do a whole lot myself. And I bale between 250 and 300 acres, 2 cuts a year.
Yep.
And I figured out the amount of, that saves me days when I figure out my net wrap time versus my twine time.
Yeah,
It saves me a few days worth of labor, it's a few days worth of diesel, it's a few days worth of hours on the tractor for your next oil change, et cetera. I mean, it's all maintenance, fuel, everything, so for what I've done, that's just, it was kind of a no-brainer, net wrap's the way to go. Even if, and I tell you, some of the hay I do store inside, I still want a net wrap, I mean, personally.
just for movement.
But you've got the factor of botulism when you start wrapping that stuff too.
The moisture content's critical. Yeah. I will also say that I sell to people that prefer sisal. I sell to some people that would prefer not to have to get off and cut, you know, and for them it's a convenience thing. So I think there are audiences for both. But yeah,
We can cut the strings on the system and pull all those off. Kind of like your illustration on those wheels with that twine around it, they seem to get around into your tires.
yeah.
Or in the lazy bush hog.
Or in the Lake Erie. Yeah, no. There's a little bit of both. Some of my hay that I feed in on the concrete, I take off sisal for, but I have others that I don't. It just depends. So, but I think that probably important to think about what your audience is, or who you're selling to, or what they're requesting from you. If you're custom baling, I think a lot of that really plays into the system. But I think this is probably one of the most critical points, is making a decision about what kind of hay you want.
Whenever you talk about the number of bales that you should get per acre, and they only weigh 800 pounds or 4 to 5 rolls, how dense are you?
So what I did there is took, that's basically the numbers that came out of that study. So I guess that's whatever they had. So they had 2 different years. So I took the average of what their weight would have been and used that to calculate it. So yeah, 800 pounds is probably a little, yeah.
I'm getting between 11 and 1200.
Yeah, and that was Wisconsin, and he did say in that article that it was super dry. So they were like 12, 13% bales, something like that. So
I try to put it dry, but I pump that airbag up pretty heavy, and
yeah,
some bales I have pumped in spirit.
yeah.
And I don't know if that's good or bad. And we did the 4x12s because we got a lot of heat. And it was easier on the equipment to carry that type of bale, bouncing up and down the fields and stuff. It was pretty nice.
Yeah. All right, so looks like we got just a couple slides on inline balers. So a little bit different than the round bales. I'm sure you probably can't see that. Similar type of operation. Basically the way material comes in, comes over the pickup, and it goes into a pre-compression chamber. So that chamber fills up. Then once it gets full, there's a stuffer that it trips. There's forks that go up, push in front of the plunger. That plunger pushes the next flake down the baler. A couple things on those. So bale density on the square baler is a little bit different. Actually, turns out it matters a little bit more in a big square baler. So all the same things affect it, but on a square baler you have these sides. So there's like a convergence section. So there's pressure on those, and they actually go in and out. And that the friction of the material being pushed through the baler is actually how you control how hard it is to push through. So that's what creates your density. A couple things you can worry with those. If you can make a bale too dense. So if you have the density setting cranked up too high and you pop it out, you can, there's expanding forces that are generated right after it's popped out, and you can break strings. Or if you're too high, then you run out of, the plunger can't take it. So those are really just the 2 things that are a little bit different that you might think about with those. I think next we have some used balers. Morgan's area of expertise.
Yeah, I know all about a used baler. This is Josh's personal story, but I'm going to say that I think this is most people who have run an old baler's personal story. He spent at least 50% of your time looking back behind you, maybe closer to 80% of the time, trying to get everything balanced right, trying to make sure you're picking up correctly. You get a crick in your neck, you have no monitor, you have no gauge on when things are full if you're not watching really carefully. It never bails when the hay is too wet. It will be very particular about the moisture content in an older baler. Josh says he used his utility knife an awful lot, and that it was particularly frustrating in July and August when he was trying to get it all unclogged in the middle of a field. There are some benefits to older balers, and then there's some challenges with them. Obviously the benefit is, one, they're less expensive. Two, they have a lot less parts that can go, they have a lot of parts that can go wrong, but they don't have the brain on them that can potentially give you fits while you're trying to get baled. They tend to have a lot of wear and tear on them, though. So if I was looking at a baler, I'd really want to think about whether or not I wanted a controller in front of my face. Do you want to talk about the technology that goes into the controller?
Sure. So now we'll go the opposite of the old baler, where you have to spend all your time looking behind you. So you have pretty much two options for in-cab control. There's the standalone bale monitor, and then there's the ISOBUS monitors. Is anybody using an ISOBUS monitor? Nobody is. I think they're kind of new and kind of probably a little more pricey. So, but has anybody heard of ISOBUS? Okay, so ISOBUS basically makes it so you don't have to have separate monitors for different pieces of equipment. So basically, it's based on the same standards that like run the controls in your car. So, the J1939 is the automotive standard. There's ISO 11783 is the ag standard. It's really all it does is it allows interconnectivity. So you can have, same way the engine talks to all the other systems on the car. It's basically the same thing but applied to a tractor. So ISOBUS is the bridge between all the communications that go on the tractor and the communications on the implement. So there's two communication lines that go back and forth. There's an implement bus and baler or tractor bus. And so by connecting those together, you can talk to each other. So that's how you can just plug it in, and then the baler can talk to the display, and so you can have just one display in the cab that can, you can run whatever needed a monitor on it. They would all run through the same monitor. It's pretty cool. The virtual terminal is actually what the monitor is. So if you start looking at these sort of things, people will say virtual terminal. All that is the monitor. That's just the human interface where you can interact with the sensors and things like that. So there's two versions of it. I guess there must be three. I don't know what ISOBUS 1 is, but ISOBUS 2 is the most common one. It's what allows just communication between the two. So you can display, like on the previous side, you can see this is a ISOBUS one. You can see what the load is on it. You can see some of the capacity stuff on your baler. It'll do some other stuff. You can see some RPMs, and it has like a bale counter and stuff like that. So all that information just comes across that bus onto the monitor. ISOBUS 3 allows communication to go both ways. So that's like where all of the cool new stuff is. So like CNH, they just came out with one of their new ones. It's ISOBUS 3. You can go, and the baler actually controls the tractor. So you can just be going through the field. The baler will tell the tractor, hey, I'm full. It'll stop automatically, tie and eject the bale, and then all the operator has to do is put the baler back in go and just take off again. So really, I'm sure, I don't know how much it costs, probably a lot, but it's pretty cool, nice things to do that kind of help operator comfort. It's definitely a lot easier than staring back over your shoulder watching the bales. So ISOBUS 3, it's ISOBUS 2, you can use implements from different makes and manufacturers, and they should talk to each other okay, but at this point, ISOBUS 3 is just, it's color specific for the ISOBUS 3. And this just kind of shows the same thing. So, I think I pretty much talked about all this, but eliminates the need for having multiple monitors. This kind of shows the different buses. So, you have all the ECUs and electrical control units. So that's all the controllers, all the sensors and stuff like that can go, and it basically just puts messages out onto this network, and then whatever other system might need the messages can just listen for them and grab what message they want. And so the isobus thing again, it's literally just a connector that bridges the two together. All right, so next thing, moisture. That's I don't know if anybody's ever baled wet bales before, or who has a moisture probe that they like. Okay, yeah, one that works pretty well. So it's kind of, we did a lot of work trying to do some of this stuff, and there's a ton of things that influence your moisture reading when you go to take one. Density of the material that you're measuring, where you stick it in the bale, crop type. So a lot of these, they're calibrated in a specific crop. So some of them will use alfalfa, some will use straw, and some of the research out there shows 4 or 5 points different between what crop it was calibrated in and the same in a different crop. So those are things to keep in mind. Some of these probes, I think this just shows a couple examples of them. One measures the RH, one measures resistance. They pretty much, below a certain point it's just dry, and above a certain point it's just wet. So, if it says it's over 30%, you can't really trust that number, but it's wet. So it's, I guess that's really all you need to know at that point. But, there's also some other more commercial onboard ones. So like this is an example of one that's made by Gazika that would actually go on the back of a square baler that would monitor the moisture for you in the cab as you're going down the field. And I guess all these you compare, you can always do it take the sample and put it in the oven and dry it out and measure the moisture change, which is the way we do it when we take moisture samples for actual research type stuff. Do you have anything you want to say about moisture probes?
No, I think they're challenging to use because there's a lot of variability. It's important if you're going to use one that you take multiple samples and try and get some averages. Some people will try and pull it straight from the field. Other people will wait till it's in a bale. It'd be nice to be able to get it out of the field, but being able to get the right compaction before you actually put it into a bale is sometimes challenging to get because it's really surface contact with the moisture tester that creates the reading. So every time you go in with a different pressure or a different leaf size or shape, you get a different reading.
Yeah, I think most of them actually say if you read the manuals to do it in a bale, not just grabbing a handful of material. They say to try and do it in a bale. All right. Maintenance. Was I talking about maintenance for you?
I'll get back in there.
Sure, that sounds good.
Oh, maintenance. Okay, so I think maintenance is probably the other sort of big cost that's sort of a question mark when you're thinking about equipment. And there's sort of 3 strategies here, and maybe some of these work better for some things and some work better for other. One is run to failure. That's where you run a piece of equipment until it absolutely fails. That's a strategy for maintenance. You wait till and something's going to go wrong, but you just go ahead and run it anyway till it happens. The second strategy is to do preventative maintenance. Ideally, if you're trying to get things done in a tight window and in the spring and summer, maybe some preventative maintenance is a good option. And what I call as life happens, this is where you don't anticipate something going wrong, but it still happens. And so we have to be prepared to do maintenance that way as well. I don't love the numbers on here, but I just want to talk about this. If you're thinking about your equipment and budgeting, you should be expecting to spend somewhere in the neighborhood of 5 to 10% of your total capital cost that's in this equipment every year to make maintenance repairs on your equipment. He runs numbers here that I think are very cheap for a tractor and a baler. So if I could find ones for that price that worked, I'd be really excited. But I think that percentage is still right. I think you need to be accounting for it, and I think certainly the cheaper your equipment is, the higher that percent needs to be for that maintenance cost, the more you need to anticipate having to do repairs. So just something to kind of keep in the back of your mind. That run to failure option, light bulbs. This is a good strategy for something like a light bulb, or the light on the front of the tractor. You wait till it goes out before you replace it. I guess you have the option to replace something before it's time to do so, but in some cases you can risk something failing that way. these are really good things to be doing only if you know that the asset upon breakdown poses no safety risk. You know, if you think like your axle has a weird wonk in it, that's probably not something to run to failure. You know, for your own safety, that's not a good idea. But you know, if you think your light's flickering on the headlamp, on the headlight of a tractor, maybe it's okay if it runs till it goes out completely. That's probably not going to be a critical, dangerous failure for you unless you're running up and down the road at night. And that it has minimal effect on production. For instance, I have a tractor seat on my tractor, and it goes like this. And it's really uncomfortable to ride on, but for me, it's a run to failure. I'm not replacing the seat until it fails completely. I just have chosen not to invest the $200 or whatever it is to put a new tractor seat on my tractor. And I'm okay with that. Some other people might not be. There's a lot of discomfort associated with that. So, you know, at some point I'll probably break down and it won't be a run to failure, but for now it is. One of the things, yeah.
Probably depends on how old your butt is.
That's true. And I got a lot of cushioning, so I'm probably in pretty good shape. But, yeah. My back doesn't appreciate it, but my butt's okay. The farm to be successful strategy, if you're going to allow run to failure on something like a hose or something like that, having those parts on hand so that you can fix them when they do break is sort of important. So if you know that the closest spot where you can get a repair done on a hose or a line, you know, is 15 miles away, and it's Saturday afternoon and it's spewing a little bit of oil, and they close at 5, not having one on hand and knowing you're going to try and get something done on Sunday and it's going to be closed on Sunday that's not a good run to failure time frame. So sort of understanding if you have the part available to fix later, you know, you're losing teeth off of your rake, you wait till you lose the teeth to replace the teeth sometimes. You know, there are things that you can decide that you're going to run to the point of failure and replace when you need to, and there are other things that really don't work well like this. If you make a poor choice, improper application of run to failure, there's definitely costs associated with it. That's when, you know, that hose breaks and you're down for a day and a half because you made the wrong decision on that run to failure. And there's time and money involved in that kind of loss. So sort of something to be kind of conscientious of in the back of your mind. It's okay to do this, but you got to be sort of prepared for what might happen if you're running into failure. This is a hose that blew off in the middle of the line. It does happen. Sometimes you know something's coming and you're still going to go ahead and run it. You're trying to get done. But it's a lot harder to replace things like this in the middle of the field than it would be if you had it at the shop or the house where you have equipment. Preventative maintenance. Planning ahead of the failure, fixing it without any production issues. Critical operation must be maintained. So if it's a piece of equipment that absolutely has to work on a given day, you should be looking at that piece of equipment before that given day to make sure that it looks like it's in good shape to run. The longer you neglect to look at something, the more likely you are to have a failure because of improper preventative maintenance. Make sense? And preventative maintenance should be coinciding with your downtime. You know, before the start of the season, that's a good time. Right now is probably when you should be looking at this equipment, making decisions, deciding if there's preventative maintenance that you need to be doing. You know, maybe you can remember now that last August or September, something did a little weird, you know, twitch in something, or, you know, it wasn't, you know, maybe your square baler isn't quite as tight as you want and you have to work on your knotters. Now is the time to be thinking about making those types of repairs rather than in mid-May when you need to be in the field. I don't really understand Josh's joke here. He says obtain parts ahead of time. That's his Valentine's Day centerpiece. I don't know that I want that on my table for Valentine's Day, but I guess it's a nice gift for someone. I don't know if anyone has a spouse that would appreciate that on the table on Valentine's Day, but I guess my husband would. And the third type of maintenance is sort of that unplanned repair, flat tire, something blows that you're not anticipating, someone's running and they hit sinkhole. You know, these are things that you shouldn't be anticipating, but they happen. And again, having parts on hand is probably pretty critical, and there is sort of an acceptance that there are going to be failures that are going to happen that are not anticipated, and that occasionally that does result in downtime, and there has to be sort of a plan in place that you're going to accept that. Let me go back to slide here. One of the things I want to say about this is if you have 100 acres of hay, this is probably going to happen if you put all 100 acres down at once. You know, so there's a risk management strategy. You have to understand that this could happen at any point in the season. And so you don't want to put yourself in a position where you have too much riding on everything going perfectly at one time, because that is inevitably when Murphy's Law will drive a maintenance strategy of unplanned repair. Yeah. Can we talk about hay wagons? You don't need to.
Go ahead.
Oh, you want me to talk about it?
Yeah, sure.
Okay, so hay wagons. Hay wagons are one of those things that aren't used all the time. And so as a result, they don't get checked. This is one of those things where you could do some preventative maintenance, check tire pressures, make sure that all your tires are holding air before you get into the season. One of the things that's kind of nice, it's kind of cool, they actually have valve stem caps that give you basically a indication on how well they're holding air. You can put them on there. You can purchase them like on Amazon, and they basically will tell you if you're holding enough pressure, and it'll show green or yellow or red if you're sort of in the right pressure or lower pressure ranges. It's a much easier way than coming out every time you want to run that wagon and checking pressure in every tire and then having to like wipe off your tire to figure out what your pressure is supposed to be in those tires. So it's certainly an option that's out there. Making sure you have the right tires on, having this kind of stuff done, it really speeds up the process. So I kind of like that. It's kind of cool. Not super expensive. I think they were, what are they, like $8 or $10 for a pack of 4. It's not a huge amount of money, and probably from a time-saving perspective, something to consider. See if you have a picture of it. One of the things I will say about hay wagons is there are a couple different types of hay wagons. If you're looking at turning a hay wagon and moving it, especially these carriers that have that sort of ball hitch in the center, they work much better than a fixed hitch there, because here in Kentucky we have a lot of field and farm entrances that are real tight. What we tend to do is we tend to come out with a load of hay and turn hard. And if we don't have something that's got a hitch like this, a ball hitch like this, something that we can turn aggressively with, we tend to bend and or break our connection points. I see a lot of welds on these types of hay wagons that don't have a ball hitch in them, and I'm not surprised by that. If you have a hay wagon that's more of a standard axle system, greasing, making sure those tie rods are right before you go in and do all this turning with a lot of weight on it is really important as well. So the maintenance on those wagons, I think in the long term, can really extend the life on a hay wagon. Hay spears break. I don't know if anyone's broken a hay spear. I actually haven't broken a hay spear yet. But a lot of people do break hay spears. I don't know if it's just the speed at which people are going through and moving hay, not paying attention sometimes. There are stronger and there are weaker hay spears out there, and the way they attach into the spear itself, the way they bolt in, some of them tend to be a little bit looser and some tend to be tighter. So there are some things you can do that can cause a break in a hay spear. I actually, my father-in-law, I guess, he has a tractor, and the hydraulic on the front end of it has a hitch in it, and he's actually driven the spear into the ground and driven right up on top. It's not unusual to see someone do that. You know, the hydraulics just turned down while he was driving on their own. And I've seen people do that before as well, intentionally or unintentionally on a hillside. They'll drive a spear into the ground. It's pretty dangerous. So being conscientious about how you're managing your spear when you're moving up and down the road, making sure you can see the point on it, all of that's really important. It's nice to have a plan B. If you have one hay spear and that's the only hay spear you have, you're probably not sitting in a good position for that failure in the field. So having at least a second spear or some other option for moving hay out of the field is probably a good thing. Baler belt life. Am I still here, or am I doing two more on here? Baler belt life is one of my sort of things. When to replace a belt on a baler is sort of a toss-up. A lot of people have different opinions on this, but belts are really expensive, relatively expensive. The baler really needs to be stored inside. These belts will get a lot of dry rot, a lot of cracking, if they're exposed to a lot of weather and a lot of sun. So this, if I was choosing one piece of equipment to store inside, this is what I would be putting inside. Any stretching or fraying on these belts should be sort of recognized. Small amounts of fraying on the edges is not unusual, but when it starts to get to be a very significant amount, we start to look at them and thinking about whether or not we need to make a replacement. In theory, we should replace all of our belts at one time so we can keep all of our tension on all of our belts fairly uniform. If we have foreign material come through and it rips one of our belts and not the others, there are ways to repair a single belt. It is an option. If we're going to do that, we really want to be conscious that we get all of our belts sort of to the same level of tightness even after we make repairs. So that's sort of one of those challenges, is that ideally you want all of your belts to be sort of uniform and the same. So when they get to a certain level of wear, it's time to maybe replace all of them. I see a lot of people replace half their belts or a third of their belts at a time. And I guess it's a cost decision that they make to do it that way. But from a wear and tear and life span on those belts, if you replace all of them at once, it is actually better.
Sure. All right, hydraulic hose failure. So hoses fail. I think this is probably I hear people complain about hoses failing more than anything, probably. A number of things happen. I think this shows you've got some hoses rub on things. Hoses get bent past their minimum bend radius. I think this shows a fitting where the little crimp-on connection didn't get put on correctly. Or you can also have dry rot and the liner gets eroded away over time. So, I think these things happen. So I think it's really, Morgan touched on it a lot, just being prepared and ready in the field for something like this to go wrong. Dust caps. So dust caps, it's dirt and dust is the enemy of hydraulic systems. That's it literally takes less than a minute to put them on. I know anybody that's an engineer would highly encourage keeping the ends covered. And it really thinks about it. I know everybody gets frustrated and in a hurry to do things, but if you do it now, by the time you come back later and next time you try to hook it up and the ball's stuck or you got to wipe off the dirt and things like that from it, it's might as well just take the time, keep the ends covered, and help keep some of the dirt out of your hydraulic system. Sprockets. All right, they didn't make many spare parts on equipment. So Josh had a joke in here saying that anytime something breaks on one of his balers, he always asks his mechanic if it'll run without it, and the answer is usually no, because they didn't put a lot of spare parts on there. So that's it. All right. So I'll let him know that his joke was good. That's it. Some things you want to look at if you're looking at a sprocket would be just any visual signs of wear. If you have the keyways get loose in there, if you have hook teeth. So I think this shows an example of one that's hooked. If that hook is more than 10% of the overall width of the tooth, it needs to be replaced. And of course, you could see other things like bent sprockets and wobble and things like that. That should be fairly obvious to see. When you're tightening roller chain, so maintaining proper tensions also important. If you have it too loose, you have a lot of vibrations and whip going on in the chain, and that reduces the life of the chain. If you have it too tight, you can run into problems with things getting bound up, and bending things also causes the chain to fail. So really on your slack size, I guess the general recommendation would be 2% of the center distance would be about the right amount of droop, but really I think most people just pull it tight and push on it and make sure it's got a little bit of give in it. I think it's a pretty common way to do it. And the other thing you got to do is make sure that you have the mesh lined up properly on the teeth. So, those rollers should really sit pretty well perfectly inside the grooves there on the sprockets. Other thing to watch out for chain failure is elongation. So most chains will run with, Josh said 2% elongation, so I think it kind of depends. For a drive application, probably 1.5% is getting close to where you want to be. If it's something that's non-critical, like a conveyor or something like that, you can probably get away with up to like 3%. So the way you do this is to, they make gauges that you can use to measure it. But really, you can do it with the tape measure too. You want to measure at least 10 lengths of chain, and you can measure it and see if the percent elongation's right in that 2% range. If so, then you should probably think about changing the chain. Oh yeah, does that make sense how you would actually do that? So this is just showing, this is a gauge that tells you it automatically, but you can measure, the distance from there to there over 10 links. So say if you had, 1-inch pitch chain, that should be 10 inches, but if it's 10.25 inches, then the chain's probably stretched and probably needs to be replaced. Does that make sense? So a couple other ways chains fail. I don't think I've ever seen anything like this, but overloaded so you can actually elongate some of those plates on the side. Unzipping, I guess I've never seen that. Have you ever seen a chain unzip like that?
Not like that.
Yeah, I would say more common would be if the pin breaks, I think would be probably a more common thing to see. More issues with them failing. So if you have a tight joint and chain that's not flexing right, you might check to see if you have anything format or stuck in it or something like that, and try lubricating it. Do we have another one on lubricate? Yeah, we do. Okay. Another one, you might have a chain where it's rubbing on something. So if you ever get to a point where you can see more than 5% of the links rubbed off, probably need to go ahead and replace that chain too. And obviously, if you have a cracked chain, or if you have one of the pins starting to work itself out, you probably want to go ahead and replace that as well. That being said, we're talking a lot about replacing chains, so it's a good idea to keep on hand a set of spare links. So keep some full links and some half links on hand. Josh recommends keeping an extra foot of chain too, just to make sure you have some spare. And also making sure that you have the right chain breaks. I don't know if you guys have spent, I'm sure you all have, trying to break a chain with a grinder and a punch and a hammer and a chisel and a vise and all those sort of things. It's probably well worth the effort to have the right size break, which I know it's kind of a pain for some of the bigger size chains, but it's probably worth it. And another thing that's really important is to make sure, these chains are operated in a pretty harsh environment. So, whatever the manual says, the operating and how often you need to lube them, it's probably worth it if you have to stop in the middle of the day to go ahead and lube the chains. It would probably be worth it too, one thing just keep in mind when you're replacing a link on a chain, you always want the closed end of the master link going in the direction of travel. So that way, if anything were to hit the chain, it would only push it on there. If you had it the other way, then you could potentially have something hit there and pop that master link back off. All right, belt maintenance. This is a really kind of visual inspection thing. You see a lot of dry rot, a lot of excessive noise. You'll see them. They won't keep tension. They'll start slipping a lot. They make some tension gauges, and they make some ultrasonic tension gauges that you can use to set the proper tension on them. But, really, if it's over tension, you can cause early failure on them. Let's see, anything else on belt maintenance? Okay, grease. So grease is cheap, parts aren't. That's a good mantra to live by. Lubrication keeps things working smoothly. People didn't they might have put the grease zerks in a not easy to get to place, but they put them in there for a reason. And you should always check your manual for how often you should do it. So this just gives an example. Pretty much anywhere that you have relative motion between components, so anywhere you have a joint and something moving, you're most likely going to have a grease point. And one that typically gets ignored is the front end of the tractor. There's grease points on there that need to be hit as well. And all right, Josh said it here too. Just because the grease fitting isn't easy to get to doesn't mean you have to. You can ignore it. So if it's not accepting grease or if it's missing, you should probably go ahead and replace it, just to prevent any type of premature bearing failure or anything like that. And follow the guidelines on how much to put. You can put too much grease on there, and it's generally just good practice. When grease oozes over the sides or comes out on top, just go ahead and wipe that off, just to prevent any kind of buildup getting on the parts. And good advice: just check the manual, make sure that you're hitting all the points, and it might take some extra help or some effort to get some. I know PTO shafts and guards and shieldings and those things get in the way, but definitely want to keep your shielding in place, even though I know it's tempting to remove the shielding and just leave it off so you can grease things easier, but you should definitely keep your shielding in place and grease all your fittings. That's my mantra on that, I guess. So bearing failure, excessive load can cause bearing failure. Heat, just general fatigue, they're wear parts, so they do wear out. Anytime you have misalignment between shafts and things like that, that can just help them fail faster. And you'll see signs will be temperature, squeaks, noises, and any type of excessive wobbles. So one thing that's kind of nice is to check the temperature on them. So you should be able to see, if you have a bearing that's going bad, you'll have increased friction in there, so it'll start to heat up. So, and what a good temperature is, you can't really say a number. It depends on how big the shaft is, ambient conditions outside, how fast the shaft's rotating. Generally, a good strategy would be, if you get one of these infrared thermometers, you could, a shaft's going to have a bearing on both ends. So if you measure them both and you see one of them is significantly hotter than the other, that might be a good indication that bearing's getting ready to go out. Hey, jury to head. Yeah, okay, so smoke, excessive noises, and heat, that's all also signs that something's going out. Guy likes to run to failure, huh? Okay. And so there you go. Make sure you keep a fire extinguisher on the baler just in case you see the smoke there. Can I talk about engine oil also?
Yeah. So engine oil. The amount of times you have to change it depends on the age of the tractor. You should check your manual. It is critical to get your oils right. It will make a drastic difference in the lifespan of the equipment to get that engine oil in there and keep it maintained. He says to wear your gloves. I just wear my leather gloves. I don't really worry about it too much, but it is pretty nasty to have it all over your hands. One of the things that is sort of a newer option, and John Deere and a couple other places are sort of pushing this. I'm sort of wishy-washy on it, so I'll give you the new technology, and then I'll tell you my opinion. Fluid analysis for oil and coolants. One of the things you can do now is pull samples of your oil and coolants and send them off and have them tested to see whether or not they need to be exchanged. Certainly if you have some reservoirs that hold huge volumes, or they have a really high dollar oil, or they have a really high dollar coolant, or some material that you don't want to replace if you don't have to, this is a way to maybe test it and determine whether or not your 500 hours is when it needs to happen, or if it can wait till 600 hours. So you might get another 100 hours or maybe more depending on how you're running your equipment. It's geared more towards construction equipment, the really big dozers, larger pieces of equipment, but certainly on some of the tractors and things, there's also options for this. It basically figures out the quality of your oil. It sort of does like a base number. It basically is characterizing the oil as it is, figuring out how much soot and stuff is picking up in the lines, how much of that ashy kind of material's in there, and then an oxidation number. That's like a pH. So as it goes through the system, it oxidizes, and that will make a difference as well. And then coolants also can be done this way. So for radiators, things like that, you can also test that. Looks at nitrates and dissolved solids, so it looks at how much dirt and such is in the system. There's a bunch of tests that can be run to test this. I think we looked online this morning. It was, for a standard test, was like $30. So not super expensive, but it's not cheap either, unless you have a fairly significant investment in replacing the volume that you're talking about. It might not be a cost-effective option. But if you have a larger tractor or something and you're really changing your oil quite often, or your radiator fluid, and you're trying to decide whether or not you need to make that replacement, this is certainly something to consider, look into.
If you buy Schaefer oil, they do it for free.
Cool. And that's
When you
convenient.
buy it, they send you with a test kit, and they
Yep,
say,
and
they'll
they'll
say
send
that theirs will double, you can double your oil change. So if it says 400, they say you can go 800, but they recommend you test it anyway.
Yeah.
They don't warrant your engine.
Yeah, so that's a big deal, some of those specialty oils, yeah.
Ideas for what do you do with used hydraulic fluid? Do we drain it out? How do you get rid of that?
I have a whole lot of it sitting around, and someone else has an idea for what to do with it.
Wait, for used motor oil?
Hydraulic fluids.
Yeah, I'll take it.
What do you use it for?
I burn it in the heater.
Hydraulic fluid, not oil. Okay.
Yeah, yeah, I can burn up to 90 weight.
So what you really need is you'll buy it from?
No.
Oh, okay. I'll talk to you.
Yeah, I have a whole bunch too. I'm like, but yeah, no, I mean, I think depending on what you're spending on your oil, and like he says, if you're getting a specialty oil and you're paying a premium for it, great. I mean, if you can take advantage of a longer lifespan on an oil, I think that's good. But I would be hesitant to do it without doing testing. So the other side of sort of that radiator thing is radiators, especially on newer tractors, tend to be real tight. There doesn't tend to be a lot of clearance behind that radiator, and they tend to build up a lot of dust and dirt, especially with hay equipment. We're stirring up a lot of dust and dirt, so we tend to clog filters and do some other things, but we also clog our radiators sometimes. So blowing off, using compressed air on the radiator. He says use a dust mask and eye protection. I unroll my hay right now, and I use a dust mask for that as well. There's a lot of dust with some of the hays in particular, so and there's definitely some larger particles that tend to be on that backside of that radiator. So when you blow them out, you definitely don't want to blow them into your eyes. You know, wear your sunglasses, wear your safety glasses, wear something. Yeah.
You ever used water?
Ever used water? I have used water on it before. If you can use compressed air, I would use compressed air over water. If you don't have compressed air or you don't have it nearby, it's better than not doing anything if it's starting to run hot.
I've got both, but I had a problem in my air conditioner, and I had a heat and cooling man came in, he's a farmer out there, and he said that he uses water. He said it'll get more areas, and he says it's less harsh on the coils. I got about 180 pounds of pressure on mine.
So you're running on on the higher end on that compressed air. Yeah, that would be pretty high. If you can run your compressed air a little lower, it probably would be a little bit easier on it. But the other thing is sometimes when you're running the water through the radiator, you get some weird, sometimes you can get it cleaned out, but other times you get built up in weird spots, the way the water runs through there. Depends on the kind of dust you have and how sticky it is and what's going on. So,
A lot of times that dust and everybody, when you use water, it's sort of like concrete.
yeah,
You know, you're
I've
more
noticed it,
problem than you are.
yeah.
I've noticed with my situation, it does better with water. It seems to get cleaner. It stays that way a little longer too. But they put the radiator, the oil cooler, and the air conditioner all right there together, and it's really hard to get all of it. But you can kind of tell that you're shooting water through all three of them and see what's coming out. But the air is just pinpointed, and it's just, did I get all the little holes in it?
Yeah. Yeah, I think for a lot of the dust, I would suggest starting with compressed air because I think, like he says, sometimes you lock in some spots depending on the kind of dust you have. But some people have a lot of luck with the hose. I know that. So, in general, clean your radiators because the tractor runs a lot better. It's a lot easier on the radiator, on the fluids to keep that temperature lower. Especially because you're running that in the middle of July and August in the heat of the day. I mean, if you're going to have overheating, running a baler, especially if your tractor is not super oversized, that's when you're really at risk for overheating a piece of equipment. That's probably one of the things that's probably sized. In my perspective, on most people's farms here in central Kentucky, the tractor is sized for the baler, or the baler is sized for the tractor, depending on which one they had first. So a lot of times that tractor isn't oversized for the baler. It's right at or just slightly above. There's an efficiency sometimes on the fuel and stuff that way. So I think a lot of people, that heating capacity on that is, you're pushing.
Things like equipment with engines, I tend to get something a little bigger when I need, so that don't work out.
Yeah. Yeah, I think this is probably the piece of equipment, the baler is probably the one that a lot of people are the closest on. So, if you're thinking about used versus new equipment, the one reason you might choose new equipment is because you think you're not going to have as many breakdowns. And the pro-con is that there's going to be lots of safety features on it. There's also a lot of technology on it. That's also a plus and minus. I mean, there's a lot of really cool things on tractors nowadays. So I don't want to dismiss that, but there's a lot of challenges with having a lot of technology on a piece of equipment. This was his tractor when they brought a new tractor home, and they got a mile down the road and the tractor blew a hose. So don't assume just because it's new it won't have an issue, because there's always something to go wrong. Obviously, there's a lot of ease of operation, a lot of technology, like I said before, a lot of things visually in front of you. On some of these newer cab tractors, the amount that you can see out with some of the newer cabs is rather impressive. Controls tend to be fairly impressive on them as well. It sort of feels like you're playing in like some really fancy virtual reality video game to get in some of these tractors. I'm not really sure what I would do if I had this many buttons in front of me. I'd probably press them all just because I wouldn't know what else to do when I saw them. But there are some opportunities as well, to get more precise on a bunch of things. So one of those sort of thinking questions I want everyone to sort of think about here is, who owns a tractor? Who owns an old tractor? Yeah, everyone knows. When you own an old tractor, you basically go out and you buy the tractor. You put money down and the tractor comes home with you and it is your tractor. You can change things on it. You can modify things on it. You can make decisions about it. How many of you own a cell phone? Who owns the cell phone, really? You own the phone, but if something goes wrong, what do? You replace it, because you have no ability to make changes or modifications or fix issues with it. So it's really yours until Apple or Samsung or whatever company it is your phone came from decides that they've done something and it no longer works, and then you have to give it back to them and get another one. On an old tractor, you can kind of repair and work along with a piece of equipment. The technology on the newer tractors tends to follow the same line as the phone. There's a lot of software on these. There's a lot of things you cannot fix. There's a lot of things that are not within your control on these newer tractors. That is not to say that there's not a reason to have them. There's not to say that there are not benefits to having those tractors, but there's certainly a big question, sort of, you have to go into the back of your mind and decide, do I want that technology, or do I want to invest in an older tractor that I have more control over? And that's probably a really radical thought here today. I'm an engineer, I should be promoting all technology, but this is a big deal for a lot of farmers. A lot of people really are thinking very hard about when they want to buy a new piece of equipment, do they want to buy new, or do they want to buy used? And so I just leave you with that thought. I'm not going to tell you what to do, but it's certainly a consideration to consider. The right to repair, this is a big discussion within ag engineering right now. We have a lot of ethical discussions about this. Do we have a problem that someone with new machinery can or cannot repair? It's just a lot of money really on the line, because if your equipment breaks down at the same time that everyone else that bought that same piece of equipment from that same dealership, the time that you're down for tends to be very high. And the cost of being down tends to be very high as well. The company has emission, safety factors. things that will cause equipment to shut down even if operation is still possible. And that is a requirement for them based upon some standards and some other things, so they are required to do that in some cases. But the question is that really fair to the farmer? So we in this room, we are familiar with this issue, and we know that farmers are concerned about this issue. So I just bring it up to sort of something to kind of think about in the back of your minds. It's a big deal.
So I will say on that, so AEM is the industry group for the equipment manufacturers. So the issue with that is, a lot of the software that they use, it's all locked down, like the diagnostic software and things like that. Their opinion is, they don't want people to be able to go and defeat emission controls and things like that. But they came out and said, I'm sure everybody's heard that, Nebraska's looking at passing right to repair legislation and stuff. So the industry groups came out and said by 2021, they're going to look at coming out with diagnostic tools and things like that to provide those to people. So really, they're, instead of having a legislative fix to mandate that they release access to some of the software, they're going to go ahead and work on coming up with a solution themselves that still kind of protects their back end with all the performance and emission controls and things like that, but still gives people access to be able to repair things for what it's worth.
We haven't seen it yet, but I'm optimistic that it's going to improve. I think there's a lot of people very concerned about it right now.
I think they said it would be 2021, so several years down the road before they
Yeah.
come up with something.
Not just on the technology side, but some manufacturers require for your warranty on a new tractor, all service has to go through the manufacturer or it voids the warranty. You can't even change your own oil.
Yeah. Yeah, it's a big deal. I mean, the decisions that they make here, it sort of follows the car industry. A lot of them have done the same thing. Yes, sir.
One problem with buying a new tractor is if you don't have a real big farm, you don't do a whole lot of farming, some of these problems don't come up until warranty's gone.
Mm-hmm.
And, it'll make it for so long, and then all of a sudden something goes out, and then the warranty's not there, and it does cost a lot.
Yeah. Yeah, and it's expensive. I mean, with that technology, replacing certain things, it would be very, well, not inexpensive, but reasonably cost-wise on an older tractor tend to be much higher just because of the sensors that things tend to be in some of these systems. So, yeah. Josh would describe himself as fiscally conservative, and I would describe myself the same way. One of the things that I would recommend doing if you're, looking at your equipment is looking for filter sales. There tends to be filter sales between now and the springtime when a lot of filters at a lot of manufacturers tend to be 50% off. And it's not just a fuel filter or an oil filter, it's also air filters. A lot of different filters you can find for fairly reasonable costs if you're strategic about it and do your preventative maintenance at this time of year, or at least anticipate the failures before they happen. So it can make justification for changing the filter a little bit better. And you can also shop around for parts. This is a good time to try and price out some of those filters and things, because phone calls are pretty cheap to make. You all said you had cell phones, so I guess it's real cheap to make because they're going to charge you regardless of whether or not you make the phone call. This is his example of an alternator for a skid steer and a tractor. His OEM Reman parts, $300 and $200. The new part for the skid steer was $500. If he goes out to Auto Place, out to an auto dealer type of store, $160 for a new one. It's an off-brand. And a Reman out of the shop was $125 for the tractor. So there are some cost differences. If you're thinking that something might be an issue, start costing out what your options are for a replacement, because it's a lot cheaper to find the price now and get it than to have it break down in the field and need it immediately, and you have to find it close enough and available at that point in time. So certainly a good option.
So I guess we can, looks like you guys already did a whole thing on soil sampling, so I guess you don't need Josh's plug to get out and get your soil samples done. Another slide made for you with your 20% chance of rain, getting rained on hay. It's every year Josh always complains when he goes and he looks at all three of the websites and see what the weather forecast looks
It
like.
almost makes you want to cut on 80%.
Yeah. So.
Oh, the one thing I will say about that is, interestingly about the weather, that 40 to 60% chance of rain does mean different things at different times of the year. So it is not the same 40%. I don't know why it's not the same 40% chance. I'm not a meteorologist, but it's just looking at how much moisture is in the air and the prediction for how likely it is for that to fall out. And that percent can mean different things at different times of the year. So, 40 to 60% is pretty risky. Yes, sir.
Is there something that you can put on your telephone that deals with farmers? I know I got a radio on my tractor that's got a farm station on it, and it seems to give a better broadcast than what, you get from the local station.
In terms of weather forecasts,
I didn't know if there was one for your phone, because I get the spots I can't hear the radio.
I don't really know of anything.
no, I mean, we have an ag weather station on campus, but it's really primarily
It's
an
web-based,
online,
yeah.
web-based system rather than a phone system. So if you're not in a spot where you have internet service, you're really challenged for that. I don't think there's anything that's really a lot better than the radio in terms of broadcast capabilities, in terms of reach.
Well,
So,
that's not what I'm saying is there just an app for farmers that just talks, like.
oh,
they
just
talk
a
about the
weather.
crops, they tell you about the weather, on that weather's band on my tractor, it's
Yeah.
a lot of satellite farms.
Yeah, there's some satellite stuff, but I don't know of anything that is just a regular radio-based system. I will ask
Yeah.
Matt Dixon, who's our meteorologist, and ask if he has any opinions, and if he does, I'll send it to.
I swear if there's a ball game or parade or something, they automatically tell you it's better weather.
Yeah. Optimistic, huh? So,
All right, so last thing for the day is talking about some UAV type stuff. So if you hear somebody say UAV, they're talking about just the vehicle. If they say UAS, it's the whole package. So it's the drone plus whatever sensors or cameras and things are on it. So you hear people say both ways, but that's really what the distinction between the two is. And so, I don't know, anybody flying UAVs for fun? A few people out there, right? We've got one at least. So if you're doing it just for fun, you can still fall under, the hobby rules. So it's, you can't fly over 400 feet, can't fly within 5 miles of an airport, can't fly over people, have to maintain line of sight. So those are like the kind of the general rules for anybody that's flying. And it's the same for the people that are doing it for the commercial purposes too, but if you're flying for the commercial purpose, you have to take a test and have a pilot's license for it. And if you have a UAV, I think you have to register all of them. Pretty much all of them now, you have to register. And that, before you fly in, will tell you where you are relative to airports or anything like that. So the commercial regulations, so this covers anybody flying anything under 55 pounds. So that's pretty much any of the Phantoms or even some of the big ones. 55 pounds is quite a lot on some of these guys. So there is a test that you have to take. I think it's paper-based, maybe it's web-based, but it's got a 90% pass rate. It mainly covers, some aerospace type stuff, but I think a lot of it's just general. Well, I guess he has a breakdown of it. Weather, performance characteristics of it, and then there's some study guides out there I think that are pretty good people if anybody's interested in doing it. So this, Josh put in the map there for you guys. So these are the airports around here. So that's the kind of the no-fly zone. I guess heliports too. So, well, anywhere around here we should be good to go if you guys want to fly. Some of the uses people are talking about these things. So, a lot of these are still in the research. So a lot of it's not commercial type stuff yet. But there's a lot of people interested in doing crop scouting. Monitoring crops over the course of the season. And doing some like NDVI type stuff so you can better manage things and make decisions earlier. stuff that people are interested in. Also using it to estimate how much biomass is actually out in the field. So going through and flying over it and using some different sensors and different techniques to be able to estimate how much hay or grass or whatever is actually out there. And I think that pretty much covers most of them. And I guess yield and quality should be your goal, so there's a nice field of Johnson grass for you. All right, I think that's it.
Those two words don't go.
Yes, sir.
Don't go together.
What's that?
What about my
Yeah,
lot?
there you go.
Okay, so I'll tell you, I'll give you my honest opinion about when they sell you on winter feed pad. One, the winter feed pad, in my opinion, works great when they're on it. They're on solid ground. There's a couple challenges with it. I'm getting wear and tear outside of the rock pad that's outside of the feed pad. And this year, I don't know how much of it is the fact that we've had like 10 inches of rain this month that's causing this issue versus what it would be in a normal year. But I'm having extreme wear and tear on the field just outside of that where they walk in and out, because they will inevitably all walk in the same pathway. And they will walk dirt out of a pathway. And they're doing it in a couple spots. They're doing it by my water tank and other places too, but they're also doing it in and out of the feed pad. So that's frustrating to invest that kind of money and then still have them walking in mud that is that deep.
What are you referring to? I missed the
He
first
asked
part.
about the feed pad that I showed a picture of at the beginning versus feeding in the mud. The benefit of it is I think we're wasting less hay. I do think they're pretty good about eating on the pad. I think they like standing on the pad. They spend plenty of time there. The other challenge I would say with it is cleaning out. I don't think that they do a good enough job warning you of the amount of storage space you might need for manure if you clean off your pad. And that's neither here nor there. I would think in most years I would have been able to get out a couple times now and spread off of that pad. I would have had a couple mornings cold enough that I could have taken a manure spreader out, and I haven't had a single one in 5 weeks, 6 weeks. So I don't know if that's a normal or an abnormal year this year. Would I still put a pad in? I have one spot where I would absolutely still have one, and on the other spot I'd probably still have one, but I would have been more strategic in how I sort of built up the area around it.
Is yours concrete?
All concrete.
We've got, ours is a rock.
Yep.
And at first it was, crushed on base, and then it was, golden class I sand, and then it was, and it doesn't matter. They stomp it to pieces, and you still got to move the manure off of it. Like you said, that's the problem I got right now is to get the manure off of it, I got to get back out where I don't have any rock.
Yep.
And where I'm going, and I can't, I'm using the skid steer, and I don't have any problem getting back with it. Okay.
So I've put mine up against so instead of like a fence line feeder, I have the pad sits out like a fence line feeder in mine. So I have, from my hoop barns, I have a gravel drive that goes up to where I come in with my equipment in and out of the pad. So for me, I haven't had to take a tractor into the field once. So I haven't rutted from a tractor. So in that regard, I'm very happy with the strategy on the pad, but the challenges are certainly still there. It is not like a non-labor system. It's not like easy to manage. Exactly.
It's like you're gonna have to go back in and repair around the edges and stuff in the spring. I usually get 2 years, and then, it's like, we spent a little over $6,000 this year with rock back on 2 pads.
Yeah.
We've been talking about, the main spot where it seems like to wear it out the most is where the we use hay wagons. And it's around those wagons is where they really dig in and so on and so forth. This year, we're kind of experimenting with leaving the excess hay and manure that's right up against it, leaving it there, because it seems like a lot of times when it freezes to that rock, and you go to try to clear it, it pulls that rock out of the ground with it. So there's a lot of money in
Winter feed pads.
trying to get some cows to one.
Yeah, I know. Yes, sir.
Would you be able to make any comments on the equipment choices for overseeding hay pastures?
Yeah. What would you like to talk about with? Do you want to talk about drills versus broadcast?
For example, I've just been doing frost seeding.
Okay.
And working with a chain power, but I'd like to move it to another level of sophistication and efficiency. But The no-till drills, I'm concerned about the spacing.
Uh-huh,
6 inches is about the smallest I've found.
yep.
Well, what do you use?
That's about what you'd use, is a
You use
no-till
a
drill.
6-inch spacing?
Yep, 6 or 7 inch spacing. The one strategy you can do, but you have to make 2 passes, is to run 2 directions.
Yeah.
And so if you're really trying to establish long-term pasture, it's not a bad option. I mean, it grows well on a cross pattern, but you're running 2 passes over your field to do it.
Any experience with broadcasting techniques that run a disc and a multi-factor or the same?
A little bit. So, let's see how to say this nicely. I've had a lot of success with broadcasting at certain times of the year and with the soil conditions and the moisture at the right level. And I don't think it matters what you do if everything goes right, like in the fall and you broadcast, or you're doing something with the frost seed and you can get it into the ground, and as soon as it gets soft, it just immediately gets the moisture it needs and it starts. But I think the challenge is if the weather isn't right, you're still not getting as much seed. You have to get seed soil contact in order to get things to start. So drills tend to get the best stance, even over the other equipment. And certain grasses will take off, in your hand if it's wet, So it depends on what you're trying to seed a little bit as well. And I'm not an expert on that. That's not what I do. So that's just my opinion.
Have you ever heard, or you've gotten any feeling of the key to the drills that you get from the state, from the fish, I'm not sure if it's Fish and Wildlife, forestry, or whatever.
Conservation, yeah.
Yeah, conservation. How do they calibrate those very often? Does any maintenance go into that, or just keep them running?
I think they keep them running.
So-
That's my personal belief, is that they're keeping them running. And actually, some drills do well, and some seeds are forgiving again, right? Some will take a 1/2 inch up to a 2 inch, and that's, if something's going to take that broad of a range on depth, you're probably going to be okay. But if something says it needs to be a 1/4 to a 1/2 inch in the ground, sometimes those rental drills tend to be a struggle to get them. You got to adjust all your hydraulics. You got to get everything squared up correctly. It can be a real challenge. Yeah.
As far as maintenance goes, generally speaking, I think with our local soil conservation, that's left up to who's managing the piece of equipment. So I don't know who's got, I think we have 3 drills in this county. 2 or 3 anyways, but, Flora Agri Supply's got one of them. And Mark generally does a pretty good job of getting that in year to get it serviced. A couple times after I've used it, and he's in the shop being serviced. So I know he's at least having somebody look at it. I'm not sure about where the other ones are, and if they're getting maintained there or not. But
Thanks.
Something
Any other maintenance or equipment or anything we can answer for you?